Okay, this is a classic problem that undergraduate statistical methods students have to conquer. There's a lot contained in these little. There's only like what I don't know, 15 characters here, but there's like a lot of stuff that's been building up, and this is hitting it hard. It really is. Let's break this thing apart piece by piece. All right, the word "fine," no problem. We've got that right. It's like we don't even need that. Now, the left side of the equal sign has a p. That means find the probability. So you want to find the probability of something, and then things start to get weird inside the parentheses because you have two z's here. All right, the z is indicating to you that we have a transformed random variable like the Doberman dog. We've just standardized. So just to build off of the Doberman example, let's back up here for a moment with the dogs. Here's black, green. So in Doberman world, I believe this is what we had. The so I'll call that X world. The average weight of a Doberman, adult male Doberman pinscher. It's not pinscher. I spelled it wrong. It's like pinscher. I'm not really sure, but the average weight is I don't know. I'll have to think of it as I'm drawing vertical lines here. Draw a few vertical lines. 75 pounds. That's a pretty good approximation. So this is X world right here. And if you got a Doberman that weighs 75 pounds exactly, well, it's not really possible, but let's just say you're like, hey, it weighs 75 pounds, right? The veterinarian says that. Your dog is very normal. It's 50% are heavier, 50% are lighter. And if you move up one standard deviation, you get to 85 pounds. Move up another standard deviation, you get to 95 pounds. That's the cutoff. Very arbitrary. For unusual, if your Doberman weighs 97 pounds, the doctor might say your Doberman needs some Slim Fast or something like that. I don't know, be unusually heavy, less than 5% probability. Okay, this problem again is a lot is packed in here to this statement. Okay, we'll get to the statement, but what I want to emphasize here is that we are still dealing with some random variable. It's just cutting the fat. It's cutting to the chase. It's saying, hey, we've already transformed. So every time you see 75, you have a z-score of 0 because that's what the z-score transformation formula tells you. Right? So for the Doberman dogs, it's each time you see a value of x, you want to subtract the mean and then divide by the standard deviation, right? So 85 would be a standard, not standard, 85 would be one standard deviation above the mean, and so on and so forth. -1 over here, and then -2 over here. Right, so these go together. These go together forever. As we saw with descriptive statistics, a z-score is uniquely identifying a percentile as well, and that leads us to this problem. It wants to know what's the probability that letter is greater than or equal to letter with asterisk. Now, often times, like, hopefully you won't have to repeat this course, but if you did, I don't know why these red vertical lines are doing this, but they are. Hopefully you don't have to repeat this, but if you do, you might take it with somebody else, and you're like, they're gonna have better writing. All right, fine. They might use this notation, z sub 0. Oh yeah, equals 0.27 or z naught maybe. There's another one too. I think I've used this before. I'm probably the only one. I just go question mark equals 0.27. That's a question mark. It's a poorly drawn one, but still a question mark. All right, so let's get to this problem here. See if I can figure out how to delete all this stuff. Delete, get out of there. Okay. Well, that's an option. I really like that green anyway, so opacity. All right, the question is this. I'm telling you, as old as statistical methods books are, you'll find a problem that looks like this. I just use z asterisk or z sub 0, z star. It's just like that. The z that is fancier than the other z, that's the one that we're looking for. So how about if I put here z question mark there, z subscript. What z question mark makes this a true statement? And a great way to approach any I think methods problem, not just in this course, but other methods courses as well, where the material is sophisticated, it's challenging, and it's built up a lot of stuff where you might be playing catch up at times because life happens. Guess and check. Guess and check. So guess a value for this right here. Just guess and then see if it makes sense. I seriously have not given this any more thought than you have. You've given it more thought than me. I just see 0.27 and I haven't conceptualized it at all. Although if I keep thinking about it, I will conceptualize it, so I don't want to do that. But let's just guess the number together. All right, ready? 1, 2, 3, and then guess. 1, 2, 3, guess. I'm guessing -2. I don't know what you guess, but hopefully you write it down or pause the video or rewind. And then notice here too, I'm really flaunting. I'm just showing off here when I start not really paying attention to the inequalities, like whether it's strictly a greater than or strictly greater than or equal to, because it doesn't matter. It's an estimate. It's a continuous random variable anyway, and it's the point is moot. Okay, so z question mark. I said -2. I can't go back on that. Does that equal 27%? And notice suddenly this problem becomes tangible. Well, hopefully. Let's see if that makes sense. Does all the area to the right of a z-score of -2 equal 27%? This is where you want to get your drawing box out. Hopefully you drew a better standard normal curve than mine. This is a z-score of 0. Right, shouldn't be so pointy, but here's -2. And the empirical rule tells us that this is actually 98%. All this stuff is 98%. That does not equal 27%, so it looks like I was way off. And now, hopefully, things are starting to fall into place for you, right? Imagine if I started jumping over, let's say here. What if I go to a z-score of -1? Or how about a z-score of 0? What's happening to that area? It's getting closer and closer to the value we're looking for. All right, so there are a lot of shortcuts here, but I want you to discover them on your own, okay? Because if you discover them on your own, then you'll understand it, and you won't even need the shortcuts anyway. So anyway, let's get this over with. You're going to go into the standard normal table, or use one of the applets online, and you're going to look for, let's see, standard normal table. You're going to look for something in the middle of the table, the body, the bulk, the center. You're going to look for 0.27. And if you're not going to find 0.27 exactly, you get something pretty close. Negative 0.61. That's what I got. Negative, so you got to figure out what z-score gives you that. So let's slide over, get out of here. Finish this sucker off. I'm making the following claim. What I did was I went into the body of the table. Let's mark that down. Body of the table. The table's just organizing all of the areas from calculus. And I looked for the closest area probability to that. There's 4 decimal places. The closest in the table that I could find was negative 0.61. The z-score associated with the value, the probability closest to this, was a z-score of negative 0.61. So now let's go back to the problem and see if we've answered it. Let's plug in negative 0.61 up here for z question mark and see if we get something that makes sense. That's the whole goal here. Again, a lot is packed into this. Notice how many, right, we've gone through a lot here. This is almost 12 minutes. I know 3 minutes of wasted time here, but there's a lot packed into these kinds of problems. They're like little puzzles. Treat them that way, and they'll treat you right. Maybe the probability that z is greater than negative 0.61 equals 0.27. Probability that z is greater than negative 0.61 is 0.27. No, that doesn't make any sense. That makes no sense. What did I do wrong? All right, well, I've got to think. Well, you got to think for this. I don't have to think anymore. I just, it's like, you just do it a while, you get it. And then you can use one of the many applets posted online and that I've shown you to double check this. But this is now a very straightforward problem. If I asked you this, you could answer an exam at 15, 20 of these in a row. You'd get them all right. Be a pretty crappy exam for the students that are our future pharmacists. Right? Wouldn't be fair. That's another day. Let's just end the video here and say that this does equal 0.27, and the answer to this problem is right here, z of 0.61.